I'm hot today, but the cola isn't cold at all. How can I make it cold in a very short period of time?
Don't worry, I will help you. Firstly, we have to put the Coca-Cola in the ice water. And then add some salt in the ice water. And stir it. Then the Coca-Cola will be very cold very soon. Hey.
Thank you. Wow, it's really cold. Why can't the sauce make the cooling process faster?
Oh, let me ask my friend to explain it to you.
In our daily lives, there are a lot of chemical reactions. Some of them are exothermic, while some of them are endothermic. For exothermic reactions, there will be heat released to the surroundings, whereas for endothermic reactions, there will be heat absorbed from the surroundings. When salt is dissolved into water, sodium chloride is changed from solid state to aqueous state, and this process is an endothermic process where heat is absorbed from Coca-Cola. So, the temperature of Coca-Cola drops, and that's why Kelvin can enjoy freezing Coca-Cola in such a short time. How about let's demonstrate this process once again in our school laboratory. Initially, the temperature of the ice water is 1 degree Celsius. Now, we are going to add some salt, which is sodium chloride, into the ice water. After stirring, it is found that the final temperature is -4 degrees Celsius, proving that it is an endothermic process. In fact, there are a few more examples in our daily lives demonstrating exothermic and endothermic reactions. When the athletes are injured, the ambulance man will use the cold pack to alleviate the pain, but why the pack will become so cold when the package is spent? In fact, there are 2 layers in the cold pack, one containing some ammonium nitrate powder and one containing some water. When the package is spent, the membrane separating these 2 layers is broken and ammonium nitrate will dissolve in the water. This process is also endothermic, so the temperature of the pack will drop to create an instant cooling effect. Now, we are going to add some ammonium nitrate into some water. Initially, the temperature of the water is 29 degrees Celsius. After adding some ammonium nitrate granules, we stir it well to make sure all ammonium nitrate powder is dissolved. The final temperature is 23 degrees Celsius. Since the temperature drops, it's proven that ammonium nitrate powder dissolving in water is an endothermic process. We have seen a lot of examples which are endothermic. How about let's see some which are exothermic? There are a lot of self-heating food products which can be served hot even though you do not have any fire source. There are some calcium oxide, which is also called quicklime, at the bottom of the container. When the button is pressed, the foil separating the calcium oxide and water will break, and calcium oxide will react with water to form calcium hydroxide. This process is exothermic. Heat is released to the food contained in the can. So, even without fire, the food can still be served hot. The bigger beaker on the left contains some calcium oxide granules. The smaller beaker on the right contains some water. Right after the addition of some water on the calcium oxide, some steam is observed. This shows that the heat given off from the reaction between calcium oxide and water is sufficient to boil the water, so this is an exothermic reaction. Thanks for watching our video. I hope you are now more familiar with exothermic and endothermic reactions in our daily lives. See you next time. Bye!